Welcome to Hope Academy. My name is Mr. O, and today I'm going to go in depth on binomial distribution. And so in front of you today, on this video, are two questions that I chose specifically because these two questions are binomial distribution based questions, but they do have different procedures as to how you could solve out the problem. And so I'm going to go ahead today and go into depth on these questions on how to go about solving these type of questions. So I'm going to go ahead and get started. So a basketball player has a 60% chance of making each free throw. What's the probability that the player makes exactly 3 out of 6 free throws? So the first thing first, they tell me exactly that their total is 6, which is going to be my end for this question, that there are 3 free throws that they make exactly, and that there's a 60% chance. 60% is going to be my P, okay? And that this is going to be what I call my K, okay? And so as a reminder, just in case you forgot what the binomial distribution is, it is provided on the AP Statistics exam, and I'm going to show it right here real briefly. I'll copy down the equation, but this is the equation I'll be using. And so the equation was NK, P to the K, 1 minus P to the N minus K, which is equals to probability of x equals to n, okay? And so when I'm solving this type of question out, the things that, as I mentioned before, that I identified was the fact that there are fixed number of throws. If this wasn't so explicitly stated and it was 3 out of 6, then I would be doubtful to consider it as a binomial distribution. But because it's very clearly laid out that either he makes the free throws or he doesn't and whatever not, that this is going to be a binomial based equation. So as I mentioned before, my n is going to be 6. So I'm going to write 6. He makes exactly 3 of them, so I'm going to plug in 3 here. My probability here is 60%. But remember that for probabilities, when we talk about probabilities being 60%, we have to convert it to decimal format, which is going to be 0.6, I mean. 0.6 or 0.6, okay? And so for this question, I'm going to put 0.6 to the k, which is going to be 3 for this question, and 1 minus 0.6 to the 6 minus 3. So I'm literally following step by step the equation and just copying it over right here, okay? And so afterwards, to solve this out, I need to use a calculator because it's the easiest way for me to solve this out. So in order to get 6,3 right here, there's a functionality on the calculator where I could actually push the math button and go over the probability and go to NCR. And the problem with this, right off, I do want to mention, is that if you just push NCR, there's going to be something that pops up that says answered. That means that it's missing it. The newer TI-84s actually do not have this issue. Most of the times you can just plug it into the little boxes that they provide. But for older versions, you do need to type the number in before you do NCR. So 6,3, this will be 20. So this value right here will become 20. And then times 0.6 to the third power, which is going to be times 0.216, and Blvd, no, my button's worn out right here, but then this button will be a little caret sign that came out right here. That will be the button that helps me get the power value, times, and if you notice, I'm breaking it down step by step on this calculator. I'm not typing everything into here. And 6 minus 3, put a parenthesis so that it doesn't mess up anything, 0.064, okay? And the reason why I break this down is because when we're dealing with multiplication and powers, you have to be careful to not mess up. So what I mean by that is that a lot of times people forget little parentheses like this, for example. When you're doing the power, you might forget that. Sometimes people are rushing and then they punch in numbers and they mess up and they don't see it because they're crunching all these numbers in. And so the best way to avoid making mistakes like this on the AP Statistics examination is by making sure that when you're punching in, you just do it piece by piece and then do it all at once in the end. So I'm going to do that like this. And so my final answer for this question will be P of x equals to n equals to 0.27648. But if you notice right here, they also mention the word probability, which I could convert this to a percentile based value. So it'll be 27.648%. And that concludes my answer for the first question. And so when I'm doing this is a very fixed based question. It's just very clearly laid out. But what happens is that a lot of times binomial distribution questions are not going to be this simple on the AP Statistics exam. They could provide this type of question, but a lot of times they will provide questions like this right below. So I'm going to read it to you, and I'm going to explain to you how do you go about doing this question. So it states, an archer has a 25% chance of hitting the bullseye on a target. What is the probability that the archer will hit the bullseye at most 3 out of 5 times? Okay, so I'm going to go ahead and start breaking this down real quick like I did last time. Be aware that this is a binomial based question. The thing that is very different from the prior question that we did up here to this one right here is the fact that they say at most. At most. This is the key word that you should catch on to note that this is going to be a little bit more complicated than the normal. Yes, it has a lot of attributes of the binomial, as in this I could identify as my k, 5 will be the n, and this 25% will be my p, which I could identify. But the part is that when they say at most 3, that means that either they get at most 3, it could be 2, it could be 1. Right? So that means that literally it will be a probability when this guy, individual, or it could be even 0, hits the bullseye 0 times. At most means up to 3. So it will be n equals to 0 plus the probability n equals to 1 plus the probability that n equals to 2 plus the probability that n equals to 3. Okay? And so when I'm doing this type of question, there's a few things I do have to know. Okay? And so when I'm doing this, doing the calculations or computation for this type of question, I need to be careful to make sure that all the possible values that I indicate are going to be aligned to what I need to do to solve this type of question. And so when I'm doing this, I literally have to do, if I'm doing it this process or, this way, I need to be careful and do it every single time. So I'll literally write it out, but you don't have to do it every single time. Just make sure you side note it. So because n equals 0, that means that this value right here that I indicate are going to be all my case. So either he got 0 bullseye, 1 bullseye, 2 bullseye, 3 bullseyes. So it'll be 5, 0. And I said my probability is 25% or 0.25 to the 0. And so we have 1 minus 0.25 to the 5 minus 0, which is going to be 5, but just for the sake of this, I'm going to go ahead and break it down. So for n equals to 1, so this is when n equals to 0. Plus, when n equals to 1, I will continue doing this. So I could do this, 0.25 to the 1, 1 minus 0.25 to the 5 minus 1. This will be when n equals to 1. And then if I want to keep going, I'm going to do 5, 2. 0.25 to the second, 1 minus 0.25 to the 5 minus 2. This will be n equals to 2. And then lastly, 5, 3. When 0.25 to the third, 1 minus 0.25 to the 5 minus 3 when n equals to 3. Okay? And what you literally have to do is what we did like the prior question right here when we punched it into calculator to get this percentile, but we literally have to do this 1, 2, 3, 4 times on the calculator, okay? And then if you do check or actually do want to go through it, you could go through this process to get the value, but there is a faster way to do this question. So just as much as there's a probability of all these probabilities individually, these binomial distribution values to help me get to a value right here, there is a opposite way of going about doing so. Just as much as I could be like, these are equals to this, I could go the backwards way and literally say that amongst 100%, I could subtract out all the probabilities of it not occurring, or aka what does not occur. So if he could get only up to 3, that means 4 out of 5 times he will get the bullseye, and 5 out of 5 times that he gets the bullseye will not exist in this value. And so I could actually do 1 or aka the 100% chance minus the probability when n equals to 4 minus the probability when n equals to 5. If you notice right here, it's a lot simpler than what we're doing here. So this is simpler. So I'm going to go ahead and do the computation. So here, this one's going to be 5, 4, and I'm doing the same procedures as I did here. So 0.25 to the 4th, 1 minus 0.25 to the 5 minus 4 minus 5, 0.25 to the 5, and 1 minus 0.25, I'm running out of space, to the 0. Okay, and I could calculate this and be aware that these two values will exactly be the same solution. Now I'm going to punch this in because this is shorter. So following my procedure right here, 1. So I'm going to first punch in this value. So I'm going to go ahead and do so. So it's going to be math, PRB, probability, enter. Oops, I forgot to put the number, so I should do that. So 54 times 0.25 to the 4th times, well, 1 minus 0.25 is going to be 0.75, and just mental math that myself. And 5 minus 4 is 1, so I'm going to punch that in. This is going to be 1 minus 0.0146. So I do 4 decimal points just to get as accurate as possible values. I'm going to do 5 math, probability, this times 0.25 to the 5th power, and 1.25 to 0 power. Anything to 0 power will be 1, so I'm not going to punch that in. So this is going to be this is going to be 4 decimal points. So this will be 1. So this will be 1, 2, 3, 4. So there's going to be 3 zeros in front. 1, 2, 3, 9, 7. So it will be something like 1, 0 around there. So I will scribble that a little bit and make this a 1. And then now I could solve it out. 1 minus 0.0146 minus 0.0010. And it's going to be equals to 0.9844. Be aware that there might be some round off error that could occur along the way, but this should generally be the solution for this question. And that concludes my explanation for today. Thank you so much for watching this video. Please do like this YouTube channel and subscribe and like our Facebook page. We'll continue to make more content like this, so please do leave a comment if there are any concepts you do want me to cover mathematically or even potentially outside of that realm. And so thank you for watching. Hope you have a wonderful day.